This is Chapter 9, Assignment Video, Problem number 2. And we are trying to figure out if we have correlation between, this is the time spent watching TV in a week, and this is the size of the television. So we're trying to figure out, do people that have bigger TVs spend more time watching TV? I wonder if there's a correlation there. So we can figure this out. We can use StatCrunch. So let's go over to StatCrunch, and I need to load, let me get rid of this old data here, and I'm going to load that data set for us. I've saved this into our group, and it's called TV, I think it's down here where I entered it. So here it is. I've got the data loaded into StatCrunch, and we are just going to take a look and see what's going on. So we go to Stat, Regression, Simple Linear. Our X values are in var1, that is the time spent watching TV in a week, and our Y variable is in var2, which is the size of the TV. Let's hit compute and see what's going on. Make this bigger so we can see this a little better. The first thing I always do is look at my scatter plot. Oh, so I already have a feeling that just looking at this, that there really isn't any correlation here, because the dots are all over the place. Here's somebody with a doesn't spend much time watching TV, but they have a really large television. Here's somebody, let's see here, spends a lot of time watching TV, but a smaller television. So I don't think we're going to find that we have correlation or not, just looking at the scatter plot. Looks like maybe slightly negative, because this line is going down just a little bit, so maybe there's a little bit of negative correlation going on, but we need to find out for sure. So we're going to run a couple of tests. There's two ways that we can decide if we have correlation or not. So let's go ahead and put everything down that we're going to need, and then we'll make our decision and make a conclusion. So we let's just jot down a few things here. This is our X value, and this is our Y value. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 pairs of data. So we would say that N is equal to 9. And let's go ahead and get this, the null and the alternative. We always set that up as rho is equal to 0, or rho is not equal to 0. So rho is your population correlation coefficient. So if rho is 0, there's no correlation. And if we get anything other than 0, then there is some sort of correlation. So we're trying to make a decision or not. Are we going to reject this null hypothesis of assuming that there is not correlation? Are we going to reject that or not? So let's see what's going on. What do we have for R? R is negative 0.01. Wow. So that is almost 0, but it's not exactly 0. We'll go with negative 0.0130. Almost 0. So that's kind of what I expected. Slightly negative, a little bit of negative correlation going on, but not much. And we need our critical values to figure out where R falls and if it's in the reject or the correlation area. So that's our chart. Let me slide that back over here to see what the critical value is. And make that bigger. I hope you can see that. So here's our alpha is 0.05. We have 9 pairs of data. So this would be 0.666. Let's move this back. Those are critical values. So we would have negative 0.666, and positive 0.666. So I'm going to come down here and let's draw this out. We do have two ways to decide if there's correlation or not. The first way is to do this. We look at R and see R can be anything from -1, perfect, I'm off the page here, R can be, this is R. R can be anything from -1 being perfect negative correlation to 0 being absolutely no correlation up to a +1 perfect positive correlation. These would be dots that are in a perfectly straight line going up. These would be dots on the scatter plot that are in a perfectly straight line going down. So where is our critical value? So it's about right here. This is positive 0.666, and down here is negative 0.666. So if we get an R value that's anywhere in this red zone or over here in this red zone, we would say that there is strong linear correlation. Now, let's look at R. R was just like right here. So there's, if anything falls in this area here, we would say there's no, oops, I'm off here. Here's R. Negative 0.01, it's just about right here. So it's fallen in this zone here. Anything between here and here, we would say there's no significant linear correlation. All right, so we've done the first method to try and decide if we have significant correlation or not. We don't, but let's look at the p-value and see what's going on there. I think we're going to confirm the same thing. There is not a correlation going on. So our test statistic, if we look over here, we look in this row for slope, follow it over. So our test statistic is negative 0.0343. That will in turn give us a p-value of 0.9736. Now, so the second way that we make a decision about correlation or not is by p-value, and that is saying is the p-value less than our alpha, and here it's not. Our p-value, which was 0.9736, is not less than 0.05. So again, we would say there is no significant linear correlation. So we do have two methods. Both confirmed that there is not correlation. Here R was not out here in the red, so it was in here in this middle where there's no correlation, and our p-value was not less than alpha. So let's make our concluding statement. We basically say the same thing each time, but we fill in these areas based on our specific situation. So we either say there is or is not evidence. There's not evidence. We did not get a low P. We did not get an R, a strong R value. So we would say there is not evidence at a 0.05 level of significance to suggest a linear correlation between time, watching TV, and size of TV. Now, since we don't have correlation, there is a regression equation in StatCrunch. It's going to give it to us right here. Here it is. We can write it down, but it's not useful. It's not meaningful because there is not significant linear correlation. I mean, it's there. We could plug it in if we wanted to and get a value, but it's just not meaningful. Your homework will probably ask for you to enter the regression equation, and then we'll make a decision on whether or not we can use it. But there is a regression equation. It's right here, and I'll just write it down. We normally call this y hat. So that would be, if it would work, that would be that the size of your TV can be determined by doing 51.4783 minus 0.029 times x, which would be the time spent watching TV. So here it is. It's not useful. We can't use it to make a prediction. The question's saying, find the size of a TV if someone watches 13 hours of TV a week. Well, we can't use this, but we still have some data here that can help us figure that out. We would simply look at all these sizes of TVs and find the mean. Find the average size TV, and that's going to be our best predictor of the size of a TV for someone who watches 13 hours of TV. There's really not a correlation, but we do have some data here. This might be helpful. That would be our best estimate to use. So StatCrunch will do that for us. here's the Y values. These are the TV sizes. And to find the size of a TV of someone who watches 13 hours a week, all we're going to do is just find the mean of these values. So we're not really even taking into account the 13 hours. We're just simply finding the mean of these Y values. So that's stat, summary stat, and column. We want to tell it to look into var2 because var2 is the TV sizes, and hit compute. Our mean is right here. So we would just say we're going to, our Y bar, okay, that's the mean. We're going to use the mean here, is equal to 51.11.